Thanks, Frank. Can everybody hear me okay in the back? Awesome. All right, I'm going to be talking to you guys today about a project I did for a mid-sized utility company where I worked on a bulk conversion of CAD files into PDFs. So as Frank mentioned, actually I don't know if he did mention, but I'm a FME certified professional and trainer. I've been with SBS for 2.5 years. SBS is a gold level reseller with 5 certified professionals and 2 trainers. All right, so what was the problem? We have a client that came to us and they have over 250,000 DGN files. A lot of these are like utility one lines, other design files as well. The problem is that they were using a MicroStation Bentley viewer to view these files, but Bentley viewer is not compatible with portable devices, so anybody in the field was unable to view the design files in the field via mobile device. This is kind of a problem. So my job was to get all of these files converted to PDFs so they can be viewed on a mobile device, and then to set up the automation so that every hour the process runs and finds any DGN files that have been modified since the previous run and converts them to PDFs so that they constantly have all the updated PDFs at hand ready to be viewed. So it wasn't just the DGN files that needed to be converted. A lot of these have background TIFF images. They also had border files as well. So I needed to make sure that I converted the DGNs and the border and the TIFF and that everything was perfectly aligned and ready to be viewed. They also wanted to make sure that I had one workspace or one process where I can hit run and it will just go through and produce all of the PDFs. I didn't want to have to click it manually for each one, obviously, since there's 250,000. Most of the DGNs would produce one PDF file, but they did have a certain type of DGN where I actually had to do a lookup to their Substation database to figure out if it was creating like a pipe plan or other things like that, or just like the default plan. And so some of them produced up to 4 PDFs. And so they wanted that functionality in this workspace as well. They also wanted to be able to customize the output, so depending on DGN type. So there were transmission, substation, and system protection DGN files. And depending on each one, some of them had to be in color, some of them had to be in black and white, some of them had to be landscape or portrait. And so I built all of those specifications into the workspaces. Oh, and then finally, they wanted me to make sure that I could automate the entire process. So originally, they were going to just have MicroStation do this conversion because you can export directly from MicroStation to a PDF. But the problem they'd have with that is it would take a lot more coding to get that process automated. And there wasn't really a way to do change detection within MicroStation to figure out like when the files are updated. So they just thought that FME server was kind of the best route as far as the automation piece. All right, so this is kind of the main process. So I'm taking DGN files from the file server. They're being copied and merged via a C# script. So what this is doing, when I originally did the proof of concept for this project, some of the DGN files came over into FME and the borders were misaligned. And I think it was because FME was viewing the border file as a separate DGN, and so it didn't have the information it needed to bring it in and aligned the way it should be. So the client created a C# script that went ahead and merged the DGN files ahead of time with the borders so that when I'm reading it into FME, it comes in as one file. And then all the border elements are actually on a level called border, and I can just do whatever I wanted to do with them. The C# script also exported the TIFF alignment information from MicroStation as well, and I'll talk a little bit about how I used that later, but FME used that information in order to align the TIFFs. So what we had to do is, because we didn't want to merge the original files with the C# script, we decided to create a temp directory. So at the beginning of the process, everything that we want, all the DGNs we want to process and the corresponding TIFFs are copied to the temp directory, and then the merge script is run on all the files in that directory. That's actually initiated by FME, and then it goes through an FME subprocess that produces the PDFs. And we end up producing a multi-layer PDF, so you can turn the TIFF on and off if you want, or turn the DGN on and off and just view the TIFF. So this is kind of an overview of what's happening in the process. So the first thing I need to do is I need to make sure that every time I run this process, it goes ahead and empties out that temp directory so that I'm not like getting duplicates of the files or trying to merge files that have already been merged, so I know that I'm starting from a blank canvas each time. So I went ahead and created a Python script that empties the temp directory, then copies the files, merge the xrefs, and then generate PDFs. Let me actually go to the runner workspace and show you how it does that. So hold on. Yeah, this is just kind of a diagram of the runner workspace. So just generally like the function of it. And I created this honestly more for me in the beginning as just kind of a design idea to figure out exactly what needed to be done. So like step 1A is that Python script I created that goes in and empties out the temp directory. Actually what it does is it only empties out the DGN and TIFF files. It never deletes PDFs because we want to make sure that we always have the most recent PDFs still in that file. And when the Delta process, I'll talk about that a little bit later too, but it goes ahead and looks at the creation tag, the modified tag on those PDFs, so we want to make sure that we don't delete them. Right. So the runner workspace has some different parameters, so you can specify your temp directory. We use pretty much the same path on our test and QA and production environment, but since this parameter was in here, it allowed you to specify your own path for that directory. There's a source CSV file that I used. It looks like this. And so I just put a list of the different directories that they actually want to process the DGNs from. And since they were pretty specific on what they wanted, I figured this was probably the easiest way to do it. So FME just reads these paths and then goes ahead and processes the rest of the workspace for each path. So the first part, you can see the Python script I use on the left, and it just goes ahead and finds that temp directory. There's a raster CSV file that's created from the script, and it makes sure that that file is deleted, and then it empties all DGN and TIFF files from the temp directory. Then it goes ahead and reads the DGN directory paths from the CSV file, and also using a directory and file path names reader. So for the system protection DGNs, they wanted to read all number files 2 levels in. So like they wanted directory 300 and directory 300/30075, but they didn't want any directories that had like text or any other type of naming format. So for those, I went ahead and used a directory and path reader, and then a string searcher and some filters to go ahead and make sure that it was only reading in the directories that meet those specifications. Then I used a system caller to copy the DGNs to the temp directory. And then originally I was using a system caller for the TIFFs as well, but what I found was that sometimes there are TIFF files that are copied over that don't, originally it was copying over all TIFFs, and some of them didn't have DGNs attached. And we wanted to make sure that we only copy over the TIFF files that have a corresponding DGN. So I used the feature reader to get the TIFFs, to read all TIFFs in, and then I ran a test to make sure it had a corresponding DGN, and then copied over the ones that do. All right. Then I went ahead, and this is pretty much just executing that C# script. I just had to do some attribute managing in front. And so what it's doing is it executes the C# script using a system caller, and the script goes ahead and merges the DGNs with the borders. It extracts the values for TIFF alignment, so that creates that CSV file that has all the TIFF alignment values, so like the path, the corner, so the dimensions and the pixel sizes and the coordinates for the lower left corner. And so FME goes ahead and uses this information to align the TIFF with the DGN. And then finally, the runner workspace just kicks off my PDF conversion workspace. So when we were testing, we did this on desktop, and so I have the DGN to PDF runner that's disabled, and that's what's used on desktop, and that's just a workspace runner. And then when we converted it to server for production, I went ahead and used FME server job submitter, and that's what you see on top, the DGN to PDF job sub. All right. So the actual PDF conversion workspace is pretty simple, as you can see. So actually taking a DGN and converting it to PDF seems like it would be pretty simple, but we ran into a lot of issues that I had to do workarounds for. And also, because of all the specifications that the utility company wanted, like the being in black and white or color based on what type of DGN and the size and things like that, there was a lot of customization that had to go into this. The main issues we had were with text. And so first I just read the DGN elements in. I created some attributes to kind of help me along the way. And then this whole part is just manipulating DGN text. One of the biggest issues we had is I found a bug in FME, unfortunately, but SAFE is aware of this and working on it. And so what happens is when you're reading dimension values in from MicroStation, we'll say you have 3 feet 6 inches. So it's supposed to come in as 3 feet with like the apostrophe dash 6 quotes, but it was coming in as 3.5, and that's not what the client wanted. And so I just did a manual workaround that went ahead and split the string at the quotes, and then did the conversion back. So we'll split the string at the decimal point, because it would come in as 3.5. So I'd take the 3 and then the 5 and then convert it back to feet and inches. So it's just string manipulation. And then I ran into issues with like degree sign was not available in the particular font that they wanted. So in order to fix this, I used rich text. So I converted all my text into XML strings. And that way, when I came to a character that the font didn't recognize, I could just tell it to use a different font for that specific character. And that allowed that character to show up. But because all the text strings were XML, then I ran into issues with escape characters. So like an ampersand, I can't remember what that actually means in XML, but it's XML would just, it wouldn't recognize it as a text until I did the ampersand amp. So I just had to use the escape character string. And then finally, their Greek letters are not supported by the PDF writer. So if you have to write Greek letters in the PDF writer, I tried every font imaginable. You can't get it to work. So the client agreed to let me just replace it with a textual representation. So like for ohm, it actually is replaced with OHM. And then the phase symbol was just replaced with PH. So. The other things I'm doing in here is there are parameters that came across, such as like sys_time, and it would just come across as like $sys_time. And so I actually used a timestamper to populate that value. I also had it populate the DGN path as well that was put on the PDF. Okay. And then I had to convert everything else, so all the non-text. And pretty much the only issue I had here was just the line styles. And so there's a whole bunch of different line styles stored in MicroStation, and it's line style 1, 2, 3, 4, 5, up to like, I think there were 36 of them. And FME doesn't know what that means. So I went in and used a PDF styler for each style. Actually, I guess there were only 7 of them, or I combined them. But anyway, and so I went in and told FME, okay, line style 1 means this, line style 2 means this, and then it made sure that it reformatted the lines based on that style. Right? So here's the TIFF part. It goes ahead and reads in the TIFF files from the temp directory, and then it reads in that CSV file that the script created, and it uses the values from the CSV file to georeference the TIFF and align it with the DGN. And then I have a tester at the end that pretty much tells it, hey, if this TIFF doesn't belong to a DGN that's currently being processed, don't do anything with it. Because if you just select everything from a folder and you have a TIFF in there that you're not using, or if you just have 3 DGNs being processed but you select all the TIFFs, then you're going to get your PDF written over with just the TIFF and no DGN elements. And so I wrote a failsafe in there that tells it not to do that. So it has to have DGN elements if it processes the TIFF. So. All right, and then there was the styling. And so one thing in here, most of this is actually figuring out what type of DGN each one is. And so for a certain type, I had to run a query against the Substation database and figure out if it was going to create just one PDF or up to 4. And that's what I'm doing here. And then there's a test filter at the end that just tells it, okay, if you're creating a conduit plan, you're going to have levels 1, 3, and 5 exposed, and the rest are not. And so it just shows the levels that need to be in that particular plan. And then it goes into this PDF format writer, and this is a custom transformer that I created. And it goes ahead and determines the extent of all the elements per fan-out attribute. So I can specify like either FME base name or whatever I want as the fan-out attribute. And then it goes ahead and grabs all elements for that output PDF and then determines the extent and calculates the orientation. So if the original orientation is portrait, then the output orientation is portrait, 8.5 by 11. If the input orientation is landscape, then the output is landscape, 11 by 17. And then it goes ahead and writes out 2 layers into a single PDF, which is DGN layer and a TIFF layer, and then produces 1 PDF per fan-out attribute. And the fan-out attribute I created here. So if you have one DGN that's producing multiple PDFs, then I gave each output PDF a different fan-out attribute. So that's how I figured out how to separate it out at the end. Okay, let's look at some pictures. So these are system protection DGNs, and the blue box in the middle is just a zoom in so you can see the clarity. And it's actually more clear than it appears on the screen. But the PDFs ended up being pretty good quality, and the client can zoom all the way in, and as I did here, and view the details. And then the text is all aligned. And here's another one. I did have to gray out any proprietary information, so if you're wondering what the gray bubbles are, that's why. And we did Substation PDFs as well. So on the left is the PDF in portrait view, and then on the right is just a zoom in so you can see the details. And you can see how the line styles came in with different dash types. This one has color, whereas system protection ones don't, because that's what they wanted. Here's another Substation DGN with a zoom in. And then finally, transmission. This is just a visualization showing you how you could zoom in on a mobile device. All right, so once I got everything configured, I had to kick off this full run. That's the fun part. So what we were doing is we ended up with 3 production servers. So this is the design I came up for the client. So in the long term, they're only going to have 1 server, but for the initial run, they set up 2 temporary production servers, and we had 10 FME engines in 1 core. So I installed the core on their permanent production server, and then set up a distributed environment with the engines. So there were 2 engines and the core on 1 server, and then 4 engines on each of the other 2 servers. And you actually have to go in, I don't know if any of you guys have set up a distributed environment before, but you have to go into your configuration files. And so you can see on the left, I just went in and added engine type. Well, actually, this is actually so that you can specify which server each one is running on. So one of the problems we were having is we wanted to go ahead and kick off 3 specific processes, right? So you have everything running once on each server. Because if you go ahead and kick off that merge script more than once on the same server, the whole thing crashes. And so I put in these tags in the configuration file to do job routing. So you can just specify, hey, run this runner workspace on server 1, and it'll run that on server 1, and then the second one will be server 2, etc. We did end up having some issues with this, but for the most part, it works. And this is just kind of estimated time. So I'm still actually working on this project, so I don't have all the stats yet for the run times. And one of the things we were having a problem with is when we went to run the process on server 2, it was still trying to run the merge script on server 1. And this is a bug that Safe is helping me try to figure out. We have a backup plan, but that's the reason I don't have actual numbers. But the estimated time would be about 61 hours total for this bulk conversion. All right, and then in the long term, we're going to drop down to 1 production server with 2 engines, and then initiate this deltas only process. And so what this goes ahead and does is it reads all of your DGN files and all the PDF files. It reads properties and gets modified date, compares the modified date. If the DGN file or the related TIFF has been modified after the PDF was created, then it goes ahead and it's processed. So it's only processing the deltas. All right, and then there's final steps. This is what we have left. So we're thinking about switching to a divided installation to where we have FME server completely installed on server 1, 2, and 3 instead of doing a distributed environment. And then we know that each process will work independently of the other. And then we just have to finish the initial run, test out the deltas only process in the production server, and then set up a schedule on FME server. So I guess the moral of the story is FME is the solution, but sometimes it needs a little TLC. You just gotta massage it until it does what you want it to do, right? So, all right, any questions?
I have the mic, and I can bring it to you for your questions, so just put up your hand and I'll bring it to you.
All right.
Okay, up at the front.
Oh, I'll wait for the mic.
Have you thought about just having 1 server and just throwing more horsepower at it?
Yes, but their main production server didn't have the capacity for that. So if I actually go back to here, you can see their main production server. They created only with, it's a dual core, and you're technically not supposed to put more engines than you have cores. So if you have dual core, you should only have 2 engines. And then I think you're supposed to allow 4 gigs of RAM per engine for maximum horsepower, I guess. But so that was one of the things, is they couldn't create a machine that was powerful enough to support all 10 engines on a single machine.
Actually, we do have an announcement. Does anyone have a bag that they're missing for a backpack? Just check around yourself, make sure you have your backpack. We've got a mystery backpack that we're trying to find an owner for. All good? Okay, we can continue on then. They're going room by room checking. Thank you.
What's the file size like for your output PDFs, since they are layered files? Because we work with PDFs as well, and we find that
Right.
layered PDFs end up being quite big with the data we put in them.
They actually, the largest one I had was about 2 megabytes. They were pretty small. So the ones that didn't have a TIFF at all were just like, I guess 700 kilobytes. So they were really tiny, but the details were good. So.
Did you have to deal with paper sizes of the original source or the DGN files, and how did you implement it?
Kind of. So what I did was, with that custom transformer I created, it went ahead and determined the orientation of the original file. And that's kind of all I needed to know, is they wanted to know if the original file is in portrait, then make it this size. If the original file is landscape, make it this size. And so all I had to do was I gathered the extents for everything in that PDF, or in that DGN rather, and then used those extent values. I just did a simple, like, divided by, to determine if it was portrait or.
So just to follow up, I guess every output is the same paper size.
No, so, let me see if I can find that. Sorry, 1 second. So this part, this is that format writer transformer, and it used the bounding box to find the extent, and then you can see almost all the way to the right, there's a PDF page formatter for portrait and one for landscape, and so they just wanted 8.5 by 11 for portrait and 11 by 17 for landscape, so I just set that in the page formatter. Mm-hmm.
I'm curious, with your file copy, there's 2 places, I think.
Yes.
Did you try to use the file copy writer, or did that not work? Or
I did not, and one of the main reasons was just because I needed to do a lot more stuff afterwards, and I know you can use a feature writer, but I really wanted to just kind of keep my stream of attributes going through, and so for me it just kind of seemed to be the best option to just use a system caller, and it just pretty much used robocopy and called that in the command line, so.
Question at the back here.
In the result of your presentation, which part is the TIFF? Yeah.
So, like, for this one, and actually that's a good point. I should have shown you guys the TIFF versus not. But I think this one, most of the background is actually TIFF. It's hard to tell. So, like, this one didn't have a TIFF. And some of them, yeah, I don't think this one had a TIFF either. So I don't have a good example of that. But some of them came through and they just have more detail in the background, and then just kind of like highlighted certain parts on top. So, and kind of the point was that they wanted to have all the data aligned so that you can't really tell which part was the TIFF and which part was the DGN. But in the actual PDFs, you can turn it on and off. So, all right.
Way over on the other side. You're right over.
Two items. One is, have you tried to create your own font for that Greek symbology? And second is, when you started this project, how did you gather, I guess, all the unique values that you need to map? Like, for example, all the 7 or 8 line styles
Mm-hmm.
from all those DGN files so that you could start the work.
All right, so the first one, I did try creating my own font, and so one of the big problems we have is that FME cannot read MicroStation fonts. And so the fonts that these DGNs are originally using, I probably spent a week trying everything I could think of to get FME to read these fonts to try to create something similar, and we just couldn't get it working. So we settled on fonts that were similar to each type. And luckily, there were only about 4 different types of fonts that were being used. And so I went through, and if it was font type 4, I set that to Times New Roman. If it was font type 5, I set that to Calibri, etc. So, second question, sorry, what was that?
How did you gather all the unique
yeah.
values?
Okay, so at the beginning of the project, I went on site with the client for 3 days, and we had meetings with every business section. So the substation business people came in and they told me exactly what they wanted. Transmission people came in, told me exactly what they wanted. And then as far as the line types or line styles, I can just view that from MicroStation. So I just went into MicroStation and checked that out, and then went in and kind of manually did it that way. So.
Yeah, it's a little trick that I've used in the past. Did you think about or attempt to just take all the fonts, all the text, and just drop it to line strings and basically make it a geometry?
And make it a, what was that last thing you said?
Just make it into like a line string geometry. So it's just, you would retain the way it looks, but it's actually a line.
Yeah, I did try several different things. I ended up using the rich text, so I turned it into like an XML string. I did try turning it into a line string, and I tried rasterizing them so that it just read it as the font as an image. But for some reason, when it did that, it was creating these weird boxes on every corner of every letter. And so I don't know if it was a setting or if it was due to the MicroStation font in the first place. What's that? Really? Okay.
I think there's another question at the back here. I thought I saw a hand up.
Oh, no, I tried that. Actually, now I just thought of that. No, I did. I told it to remove all the insertion points, too. And then it's still... Yeah, so... Okay, we can talk about it later.
So this isn't exactly a question, but as far as those symbols, you might want to try 2017.1. I'm pretty sure I fixed that. So
Okay.
yeah.
Yeah, unfortunately, we were already in production before 2017 came out, and they did not want to upgrade after they were in production. Yeah, no, I do realize that a lot of the stuff was solved in 2017, but unfortunately, utility companies in general don't like to change that quickly, especially not once you're in production. So, no offense to utility companies out there.
Okay, we've got about a half-hour break, so if those folks that want to stay and pepper Courtney with more questions, feel free to stay, but I'm sure other people need to get some refreshments. Thank you so much, Courtney.
Thank
Awesome
you.
presentation.